My name is Mohammad Pour-Ghaz, and I'm a professor of structural engineering and mechanics in the Department of Civil Construction and Environmental Engineering at North Carolina State University. I'm the director of Sensing and Materials Research Team Lab, SMART Lab for short. In my lab, we are studying behavior and mechanics of concrete and cementitious material. We are trying to understand chemical, physical, and electrochemical processes that happen in concrete materials. Concrete is everywhere, from bridges to pavement to high-rise buildings, and some of you might even have heard about concrete ships and concrete canoes. Now take an example of a bridge structure. We design bridge structures to last 50 or 75 years, and in some cases we suddenly realize after 10 years or 15 years we are seeing some sort of cracking, degradation, and corrosion of these structures. And when we look very closely to this, we realize that all the de-icing salts that we put on these structures during the winter has made their way into the concrete, have physically and chemically interacted with concrete, and even has caused the corrosion of reinforcing steel. Now, the question is, how can we measure how fast water and different de-icing salts move through the concrete? To do this, we use different techniques such as electrical impedance tomography or neutron and X-ray tomography to look at water while it is ingressing through the concrete and measure its speed. Now, alternatively, we can ask if there are alternative materials to concrete that we can use in our infrastructure. So in my research team, we also look at developing different types of cementitious materials that are not cement-based or Portland cement-based, that do not have environmental loading, they do not result in a lot of CO2 emission. And our focus here is to understand their structure at micro scale and nano scale. In addition to this, in my lab, we develop a lot of sensing methods and sensors. For example, we have developed the so-called sensing skin for smart infrastructure. You can think about it as a wallpaper or paint that's applied to the surface of the structure. This makes the structure smart in one sense, that you can detect cracking over a large area, you can detect corrosion, or you can even detect thermal loading and temperature changes on the structure. We are also looking into how we can store a little bit of electric energy inside the concrete, and by monitoring that electrical energy, we can say something about the cracking, loading, deformation, or otherwise harmful processes that happen inside the concrete. Now, you might be thinking, what does a graduate student do in your lab day to day? I'm an experimentalist, and my graduate students are all experimentalists as well. They spend majority of their time in the lab performing measurements using state-of-the-art equipment and using analytical material science method to do measurements of materials. And they spend the rest of their time using computational simulation or develop mathematical and analytical modeling to understand the experimental results that we have gathered. It's a lot of work, but it is a lot of fun.